Okay, we're going to go ahead and jump into our exit slip answer key for lesson 214. And our I can statement was about using equivalent ratios and ratio rate tables to try and graph things, to understand situations and graph them on a coordinate grid. All right, so we're just going to look at one problem here about the Ingalls family old car used 6 gallons of gas to drive 162 miles. Okay, so there's our rate. Every 6 gallons, they go 162 miles. So what they want to know is what's that unit rate. Again, we talk a lot about getting it down to that unit rate, which means get it down to 1 gallon, something with a 1 in it. Okay, so far I've got 6 gallons. I'm going to go ahead and put the label by it, by 162 miles. And we need to get this down to 1 gallon. How far does it go on 1 gallon? So we know we can divide by 6. To do ratios, keep the same rate, you got to use multiplying or dividing. So 6 divided by 6 gets me down to 1 gallon. And then I also need to take 162 divided by 6 to make it 6 times smaller to keep that same rate. And if I do that work, I've already done it, I know I come up with 27 miles. So in other words, we get every 1 gallon in this car, they can travel 27 miles. All right, so what is the unit rate? I could say a 1 to 27. You can also, in this, when we're doing miles per gallon, you could write 27 miles per gallon, MPG. That kind of is talking about question B. What does the unit rate represent? It represents miles per 1 gallon in this case. Okay, and we write that as MPG, miles per gallon. Okay, if it wants that unit rate, we could have also written it like this. A 1 every 1 gallon gives me 27 miles that I can go. Okay, so we're going to try and draw a ratio rate table here to show how much gas that the Ingalls old car used to travel these distances. So we're going to have to try to figure out when they go long distances, how much gas are they going to use. And again, you can kind of plan out then on trips how much money it's going to cost you for gas, again, when you're trying to figure out your budget there. Okay, and all of you will do that at some point. So what I know so far, I'm going to start with the unit rate, and you can go ahead and make your table. I pre-made mine there, but go ahead and make that. And I'm going to write in that every 1 gallon I get 27 miles. All right, so I've got to figure out how much gas did they use to travel 243 miles. So in other words, I've got to get this to 243. How many miles? So what would that be for gallons? So I think the easiest way probably in this case is to look at it comparing gallons to miles. I know 1 gallon, you go 27 miles. Remember, so multiplicatively, all I'm doing is taking 1 times 27 to get to 27. Every gallon I can just take times 27. So if I know the miles, I can do the opposite and divide by 27. So I could take 243 divided by 27, again, and that's going to get it back to the gallons because I multiply to go this way, so I have to divide to undo it because 27 divided by 27 is 1. So take 243 divided by 27. If we do that, do the math, I've already done it, you'll get 9 gallons. So you'd have to buy 9 gallons of gas to get to 243 miles. And we can do the same thing to go 378 miles to his cousin's house. And if I want to get to 378, again, I'm going to use this unit rate one to help me, and I know that every gallon is 27. So if I just divide by 27, I can get it back there. So 378 divided by 27, you will get 14 gallons. And really, in my ratio rate table, this is all I need to do to solve these two problems. Okay, so my answers would be, how far did he go to get to the coast? It'd be 9 miles, would be the first answer, and the second answer, if we wrote it out, would be 14. All right, to get to his cousin's house. So in the last question, the Ingalls' new car now that they have uses 5 gallons to go 130 miles. I'm going to write the ratio. Every 5 gallons, you can go 130 miles. And I want to know now which car goes farther on 1 gallon of gas. Which one has better fuel economy, so you're going to save money in the long run? Which one will go further? So again, if I get it down to the unit rate, it's pretty easy to tell. So I'm going to divide this by 5 to get it down to 1. So I must also divide this by 5. And if you take 130 divided by 5, you're going to get 26. So in this case, we know that 1 gallon of gas will go 26 miles. So which car goes farther on 1 gallon? So in other words, which one gets better gas mileage? And how do I know? Well, my old car got 1 gallon, went 27 miles for them, and the new car goes 26 miles. It's pretty close, but not quite as much. So which car goes farther? You would say the old car. And how do you know? I would just say the unit rate is 1 to 27, not 1 to 26. And that's why it's a little bit better. And you can even tell me it gets 1 more mile per gallon. It's not going to save you a lot, but it gets a little bit better gas mileage. All right, so this is the kind of stuff we can use to help us set up. The problem we're going to look at now is to try to graph this situation. So I'm going to switch screens here, and we're going to go ahead and we're going to kind of graph to see what this looks like on a coordinate grid, which is our I can statement, and we've been learning to graph on those, so we're going to apply that to a real life situation. So again, I'll pause this so you guys can make sure you get all written down when we're watching this. For right now, I'm going to switch over. And I've drawn by hand here, so it's pretty accurate. Trying to show what this might graph and look like in a coordinate grid. And guys, in the coordinate grid here, I've only drawn quadrant 1 because it's positive, positive. I didn't need the other 4 quadrants with negatives and things. So this is a big quadrant 1. And on the bottom, I've got our gallons. And here is how many miles they went, because the 2 things I'm comparing there with my ratio. And notice I labeled by 30s because when we made our chart, you might not be able to see this, but I rewrote this. We knew that 1 gallon of gas took us 27 miles. So our goal is that we're able to graph these situations. So in this point, I start down here at 0. And if I go over 1 gallon of gas, I have to approximate here because I went by 30, so I'm a little under 30, so that would represent 27. And then 2 would be 54, so I went over 2 on the X, up 50 to 54. And you notice when you start doing that on all of these different dots, 3 miles you went 81, or 3 gallons. 4 gallons you went 108. And you notice the dots start to line up, all right, because things are increasing at the same rate. So every time I go over 1, I should go up 27 more. Every time I go over 1, I go up 27. So in this case, it's keeping that same rate, so that's why it's a straight line, because it increases at the same rate. And I even went clear over to 9 like we did on the question on the other page, and went up to 200 and I believe it was 43 miles, 243 miles. And notice how it still falls on that straight line. And when I went to 14, that went 378 miles. And we're traveling at that same rate, so you'll have that straight line. So your job is you're going to have to be able to use those ratio and rate tables and then be able to graph it. And when the rate's the same, you should have a straight line. And depending on rates, you can talk about slope and things, you get more complex, but sometimes if you're traveling, the line will be, okay, if you get better gas mileage, it'll be more straight up and down. Sometimes it can be flatter based on situations. And in this case, this is what this would look like graphed. If you're getting 1 gallon, takes you 27 miles, this is the graph.